Here we are at the final piece of the design puzzle. Up to this point, we've learned all of the different symbols and arrows and how we can integrate these together to create the flow of our program. And let's do a quick little review just to bring everybody back up to speed. First of all, let's look at the different symbols. So we start off with the rounded rectangle, which represented our start and end. We had our parallelogram, which represents our input and output operations, so our read and display. Then we had our processing command, which is all about set, calculate, increment, rounding, things like that. We had our connectors, which acted like our teleporters or our to be continued symbols. And then we had our Canadian flag symbol, which represented our subprograms, our modules. Great. But the last lesson we learned all about decisions and how to make decisions within our flowcharts. And we showed this in a number of different ways. The symbol that we use for this is a diamond. Now, there's three different structures when it comes to making choices in our program. There's the structure where you have only a single choice. So there's the standard flow of the program, and then potentially it could break off into an alternate flow and perform a different sequence of actions. So we have a true-false question. And if that question is false, the program just continues as normal. However, if the answer to that true-false question is true, then it will break off and execute some code, a sequence of code, before it rejoins back with the rest of the program. Two choices is a little different. In two choices, there is no standard flow at that juncture. In reality, it kind of breaks off and we have to go one way or the other. So we end up with a situation like this, where we have a true-false question, and in one direction we say no, false, in the other direction we have true. But both of them have their own individual sets of sequential code. But either way, whichever one finishes is going to then join back with the standard flow of the program, and things will continue. We got to pay attention to these directional arrows. This shows us the flow. You'll notice that eventually things join back up and they keep going. And the whole point of that is to keep, imagine if this were water flowing, if we don't keep it all focused, then it spreads out and we don't know what's going on anymore. So that's the first two setups that we had for selection. The next one was all about multiple choice. Now, this was called our case structure, and it really represents if-else-if statements and switch statements. Now, when we look at it, the first thing that comes to mind is a switch statement. But in reality, when we're looking at the different scenarios, the different cases, it can and most likely will actually be implemented as an if-else-if statement. Why? Because usually there's only a few circumstances in our given programs where we're checking for exact equality. Now remember, when you use a switch statement, you're checking to see whether two things are equal. If-else-if statements allow for things like less than, greater than, or ranges of data. We can't do that with a switch. So what happens is when you look at it, when somebody hands you a flowchart and says program this, you have to look at that structure and say to yourself, should I use an if-else-if statement or a switch statement? And to do that, you can analyze the code and you say, oh, well, in this case that we're checking for equality every single time, so a switch statement makes sense. Okay, so what do they look like? Well, we have an arrow that drops down into a diamond, but this time instead of a true-false question, we use that keyword case. And what we're doing is we're saying we're going to compare this variable against a set of scenarios, a set of values. So we have comparison A, B, C, and D in this example. So that's 4 comparisons. So it might be a switch with 4 options, or it might be an if-else-if statement with 3 else-ifs, right? If and then 3 else-ifs. No matter what, they're each going to go in and implement their own sequence of code. And when they're finished, the flow continues on, joins back up, and continues on. So we did all this during the last flowcharting lesson. We joined all these symbols together with various arrows. There were a few rules when we use these arrows. Number 1, your arrows must be horizontal and vertical, so up, down, and left and right. They can never go on angles. They can never go on curves. They must be perfectly horizontal or perfectly vertical. They don't ever cross. You'll never see that, at least you shouldn't see that, because that just adds confusion. So you can have right-angled turns, you can have straight lines, and you can have join setups. All right, let's get into what actually matters today. What new thing are we looking at? So today we're looking at the idea of repetition. How do we add loops into our flowcharts? Well, I got some good news for you. You don't need anything new. No new symbols today. Today we're just looking at it and saying, well, how can I emulate the idea of a loop inside of a flowchart? Well, good thing is we know that loops are made up of three parts: a comparison variable, a comparison statement, and then a change statement. So what we have to do is create a system which visually shows that in our programs. So let's take a look. So where was I? Yeah. So here's our example. We want to draw a flowchart for a simple counted loop that iterates 10 times, and all it does is output the value of the counter variable every single step. That's it. That's all there is to it. We're just got to make sure that it iterates 10 times. So it might be 1 up to less than or equal to 10, or it might be 0 up to less than 10. It depends on how we set up that loop. So what's it look like in code? Well, in a flowchart. This is a flowchart with a loop. Pause the video for a second and try and work your way through this. Just think about the logic that has to occur if you were to replace that with actual code. So we can see here that this chart just looks like a regular flowchart. The difference is we finally see an arrow that leads back in to a previous point in the program. We've just went up. We've just went up the flow. So let's analyze the logic. The program comes in and it starts off and it sets count equal to 1. Oh, there's our comparison variable. We've set up a variable, we give it a starting value, 1. Okay. The next step should be a test comparison. Oh, look, if we watch the flow of the arrow, it goes down into this diamond, this decision structure. It says, is count less than or equal to 10? Remember, we're trying to loop from 1 to 10. Yes, true. Then display the count on the screen. Then increment. So that means add 1. We're going to add 1 to our count variable. Why? Well, now we got to come back and we got to test it again. So you can see this loop structure. Just like our counted loops, we had a for loop that had 3 parts to it. The first part was set up that comparison variable, but that only happens once for the whole loop. That was step 1. Step 2, 3, and 4. Step 2 being the comparison, 3 being the code, and 4 being the change. That's what really loops. 2, 3, 4, 2, 3, 4, 2, 3, 4. So every time increment is done, we got to go back and test to see whether we need to go back into the logic or go back into the loop again. And eventually it's not going to, because this change step, this increment count, is adding 1. And since it started at 1, it's eventually going to get up to that 10. And then we're done. So that's a fairly straightforward flowchart. Let's look at something a little bit more challenging. You've seen this program in reality before, but now let's look at the design for it. What is actually happening in this program? Pause the video and analyze it. Try and work out what's going on here. So if you come back now and you've figured out that what's really happening here is this is our password program. The password program that we've built multiple times this semester. Now let's follow the flow. The very first thing that happens is we have this variable called password and we set its value to unlock me. Below that, I've created a count variable and set it to 0. Oh, that tells me that we're going to be creating a loop. All right. So we go in, we say, is count less than 3? Well, what's count doing? What is this actually counting? Yeah, it's going to count our loop iterations, but really what it's doing, it's counting how many guesses we have left. How many guesses the user has left, I should say. So if count is less than 3, so if there's still guesses remaining, go in and ask them for a password. Read in that password. Compare that password. If that password is true, if we matched it, then we don't need to do any more code. We're going to display access granted and then just continue on. This is the equivalent of a break statement. What's just happened is as soon as we got that password, we said, yep, we're done. And it broke and went right back to the flow of the program. But if we didn't get it, if we didn't get the password, that means we're going to display, well, try again. And we're going to add 1 to our count variable. Oh, so now we've just used up one of our guesses. The flow comes back and links in just before the decision. So we ask again. Now count is 2. Is 2 less than 3? Yes, it is. So it comes in, it asks for another password. It retrieves that password, and continues on by saying, does it match? If yes, we're done. If no, continue on and ask for another one, incrementing count. So at some point, we're gonna get to the end of this loop by either running out of guesses or correctly getting the password correct. So this is a more complex flowchart, but it still follows really the same path. This one actually has decisions within decisions. So we have some nesting going on here. Not a nested loop, but definitely nested selection. So that's where we're going to stop. You're going to have a little bit of practice work to help apply this, and then we're going to be going forward in the course into some new areas that should challenge you in different ways. Good luck.